Right, welcome to another maths school video. We're now going to look at double function machines. All right, there are 3 stages to this one. We're going to kind of cover them all off today because I think the first few are relatively straightforward. So the first one is finding the output. All right, so a double function machine is effectively a little bit like a function machine, but 2 things happen to it. All right, so if you've seen the function machine before, and if you looked at one of the videos, you will know what that is. But if not, it's about basically putting numbers into something, and then it gives you an output effectively. So the number goes in, and the number comes out. All right, and two things will happen to it. Okay, so double function machine. So we've got a number which started with a 4, and you can see that I'm going to add 3 to it, and then I'm going to multiply it by 2, and it's going to give me an output. And all I'm after really is the number at the end. All right, so this is not big maths by any shape. It literally is just follow from left to right as you go. All right, so it sometimes helps to kind of put the partial solution in the middle, so we know that we've done. All right, so 4 add 3 is going to give 7, and then you multiply it by 2, and it gives you an answer of 14. And it's as straightforward as that. Okay, you literally just follow it across the line. All right, nothing more complicated to it other than that. All right, so let's have another look at one really quick. So let's look 8 and divide by 4. That's going to give me 2, so that's the number in the middle. And then we're going to now add 6, which is the next bit, and that's going to give me an answer of 8. All right. And then finally, just one more. Again, it's not complicated. So 3, multiply it by 7, which is going to give me 21. And then subtract 5, which is going to give me an answer of 16. All right. So that is a double function machine because 2 things have happened to it. All right. So that's the process. You put your number in, you get number out. Easy. All right. But what happens if I'm trying to find the input and I've got the answer? All right, so maybe the one I've got the answer at the back and I'm trying to find out what's gone on. Well, this is about working backwards. All right, so if I consider this first example, I added 5 and then I multiplied by 2 and I got my answer of 14. Right, so if I am going to work backwards, then I need to consider how to go back from multiplying by 2. Then I need to do the inverse of that, which is divide by 2. So what's 14 divided by 2? That's going to give me 7. And then what was my first step? Originally I added 5, so if I'm going backwards, then I need to subtract 5. That's the inverse operation. So take away 5 from the 7, and that's going to give me an answer of 2. All right, and I could check that. Is 2 add 5 multiplied by 2 14? Yes, it is, because 2 add 5 is 7, multiplied by 2 is 14. All right, so I can easily check. Let's just look at one more. All right, so again, we've subtracted and then we've divided and we've got an answer of 2, so we're going to go backwards. So the first thing we need to do is multiply by 6, which is going to give an answer of 12. And then we need to add 1 against the inverse of that one, and that's going to give me a 13. All right, so that's going to be a solution. So that's what we need to do. All right, so double function machine, start with output, then input, just working backwards, and that's pretty much it. And the other thing that you might get is they might ask you to find the rules that go in between. All right, and that's a little bit more complicated because with one specific thing, it might not be as clear cut as that. All right, so here they've got 2 numbers going in and 2 numbers kind of coming out, and a variety of different things that could have taken place. All right, so this is where you need to leave it a little bit more kind of in terms of what you think might have happened. All right, so find the rule. All right, so with this one, you can see they've added 1 and then multiplied by 2. Now, how could you check that? I mean, because there's all sorts of could have gone on with there. So let's go back a step one more. Because if I looked at this one, then if I added 5 to both of these 2, then that's going to give me 8 and 12. All right, and then what? Because whatever I do to the first one, I have to do the second one. It's not going to work, is it? Because I've already got to 8. And if I add 10, then that's going to give me 13, and then I need to take away a different number. So this is a bit about trial and error more than anything else. It's trying to think about what might happen. Well, if you look at these 2, is there a relationship between either of these 2? Not really, because 2 steps have taken place. So you have to think very, very carefully about this one. Not easy at all to try and figure out what's gone on with 2 specific steps. So you're going to trial a few different things. So in here, you can see what the solutions are. If I add 1 to both those, I've got 4 and 8. And then, of course, they can both be doubled. And that will give us our 2 solutions. And it works for both cases, all right? So let's have a look at this one. See if you can spot something, anything similar to this one, okay? Well, if I look at these numbers at the end, well, if I've learned anything from the one above, then I doubled at the end, didn't I? So if I think about these 2, well, if I half these 2, I'm going to get 2 and 8, aren't I? 2 and 8. So how does that relate to these two? Well, it's 2 less, isn't it? So if I subtract 1 from this one and then multiply it by 2, would that give me a solution? Well, it would have done, but of course there's a different solution to it. All right. So here we've got multiply by 2, but that's going to give you 6 and 18, and then subtract 2. All right. So there are different options. You can see that what I said was completely different to what was on here. So let's go back to what I suggested. So let's have a think. I suggested you take away 1. That's going to give you 2 and 8, isn't it? Yeah, 2 and 8. And then if I double them, that's going to give you 4 and 16. So that's going to give you a solution. All right. So looking at this question, now this is the solution that they're given, but clearly there's more than one. All right. All right. Let's have a look at this last one. See if we can figure it out. All right. So our numbers are going down. So let's have a think. These are multiples of 5. So if I divide them by 5, what do I get? If I divide it by 5, I'm going to get 3 and 7. All right, so let's have a look at 3 and 7. Well, 3 and 7 over here, they're 4 less, aren't they? 3 and 7. So if I divide by 5, I should say, divide by 5, and then add 4. Let's see if that works. Divide by 5, and then add 4. There you go. All right. So it's a little bit of trial and error. All right, it really is. It's about trying to think about both sets of numbers and what that gives you in the outcome. All right, so quite a tricky one a really kind of tricky one to do with double function machines, especially considering what we started with. All right, so let's hope you don't get something as complicated as that one, and let's hope nothing like this second one, which gives you 2 different variations. All right, because when I was doing it, that's not what I had, but of course I think my solution also worked. Okay. All right, so just be very, very careful. It's the kind of question I would probably say leave to the kind of back end and maybe come back and try a few different versions. Okay, all right. Anyway, thanks for listening. If you want to be a practice on that, please do visit math-school.co.uk. Link is at the bottom. But thanks for listening.